Okay, so this week we're going to be looking at some example problems where we're writing and transforming linear equations as still part of our linear review unit. So to start with, we're going to look at a couple of forms of equations today. One is slope-intercept form, which is y equals mx plus b. That's because you see a slope, m, and an intercept, b, which represents the y-intercept of the equation. So what we want to do is to make this equation look like that. In other words, we're solving for y, getting y by itself. So this requires opposite operations. First, we'll subtract 3x from both sides, which means that these cross out on this side, and I'm left with a negative 2y. Now on this other side, we cannot combine negative 16 and negative 3 because they're not like terms. This has an x with it and this does not. So that means they just drop down into my answer, negative 3x minus 16. We're almost finished. We have to get y completely by itself, so there's still a number in front of y. To get rid of it, you divide everything by a negative 2, because whatever you do to one, you have to do to all. So now we've got it by itself. What we're left with doing is some reducing. Y is by itself. A negative 3 divided by a negative 2. A negative divided by a negative is a positive, and we can't do anything else with 3 over 2, so we leave it as that fraction, 3/2. There's no need in making this look like a decimal because this says rise over run. A negative divided by a negative is a positive. 16 divided by 2 is 8. And here is our transformed equation from our original to y equals mx plus b. We're going to look at another example now about point-slope form. This is another type of equation that we've been working with in our linear review. And you'll see, just like this one, it was called slope-intercept because we talked about a slope and we had an intercept. This form is called point-slope because to use it, you have to have a point, x1, y1, and you have to have a slope, n. So if you're given the following example for your instructions, we want to write an equation that goes through the point 4, negative 4, and is parallel to this equation. That means here's the point that we're going to use, and we're going to label this x1, y1. And that's going to be information that we use to plug into the formula. Now to find m, we have to use the information that we want a line that is parallel to this line here. Parallel just means that we're going to use the same slope from this equation. And this is a y equals mx plus b, so we know in there that m is the number in front of x. This time I don't really see a number, so I'm going to put a 1 right there in that. That means my slope for this equation and the one that we are going to make both have the same slope of negative 1. So now that I know what m is, and I know what x1 and y1 are, I'm going to plug it in to my point-slope form. Y minus y1 is negative 4. Equals m is negative 1, parentheses, x, there's a minus in the formula, and x1 is 4. We're almost finished. We just need to simplify a few things to make it truly this. Actually, just one thing. A negative times a negative is a positive. So instead of this, I should write y plus 4. And there's nothing else to reduce. The remainder of the equation is in the correct form. So here is our final answer for writing something in point-slope form. Y plus 4 equals negative 1, parentheses, x minus 4. Okay, so we've done 2 examples today, one in point-slope form right here, and 1 in slope-intercept 1. Sometimes, as you'll see in an assignment in class, it'll ask you to do one or the other, or it might ask you to do both. It might start off this way, and then your job is to make it look like this. We can do that. The only thing left I would have to do is distribute this all the way through, and then I do the same process that we did here. Now we're going to use these examples to work some problems in class.